Okay, we're over here on the west side of the structure. This is the electric meter, 240 volts, should be sealed on 3 sides. We should have a slip joint. Power comes to the house below grade, comes up this conduit. You see how the conduit is slipping right here because we do not have a slip joint. In the 80s, we didn't put slip joints on much of these things. So we learned, and we're learning now. The grounding rod is not properly buried. Okay, it's a 8-foot grounding rod. It's not supposed to go down 7 foot 6 inches. Now it's possible, I doubt it. It's possible that the electrician had the code inspector come out here and determine whether there was enough resistance to meet the code, and then it got approved. I just know that it's sticking up. Rain gutter discharge is too close to the house. Tree too close to the house. Erosion under the driveway. Inside the garage west wall is our electric load center. Our service panel, our breaker box, call it what you will. This is our main service disconnect. We should have a main service disc. In the 80s, this is the way we did it. We should have an electric service disconnect on the outside. It says emergency, but we don't. Here it is, 200 amps. L1 and L2 coming in. All right, we should have protective booties around them. All right. Non-conductive is what it says in the code book. And that could be cardboard, that could be neoprene. I've seen both. Both are acceptable. And over here, this is called bundling. Okay, even my house has bundling. Even the illustration that I'm going to bake into your inspection report is somewhat apologetic about bundling. But no. See, L1 and L2 and your main neutral coming in here. That doesn't have to be covered as of yet. Okay, they come in through a large knockout. We have these large knockouts because we don't know where this box is going to be installed. So the manufacturer made it easy for everybody. And then the manufacturer made it. See all these little holes? You got them up here too. See all the little holes? Okay, these are for these. You're not supposed to bring more than 2 wires in at a time. Together. 2 wires in and together at a time. Alright? You put them all in there. It's called bundling. It's called the skin effect. It generates too much heat. You'll probably never have a problem with it. Okay? It's like that at my house. My house is not for sale. You should not have to live like me. Was it done right? No, it was not done right. There we go. Coming all along. These are our circuit breakers. These are hot. They're colored white. These are our neutrals. They're colored white. How do we know this is hot? Because we're not stupid. If you don't know that's hot, you don't belong in the box. But the fact is, just like this, if you don't know that's the main neutral, then you don't belong in the box. But we've wrapped it with white tape so that anybody, no matter their skill set, it's just kind of like dumbing it down. I get that. Is that going to affect the operation? No. But there should be black tape or black paint on these whites. So we've got white hots coming in. Got white hots coming in. Now moving on along. 30, 20, 20. That's pretty good. 15. Okay. The breakers seem, at first blush, the breakers seem like they're okay. So let's delve into this a little harder. This 45 amp breaker right here with a tie, that goes to the condensing unit. The condensing unit is rated for 35. This breaker is larger than the manufacturer specified. So this breaker will not trip in a timely manner to protect your condensing unit. I'm going to touch base on that a little bit in the condensing unit video. There's going to be some overlap in some of these things. Okay, so our condensing unit is overfused. Our clothes dryer, that'd be 30 amp right over here. 5. $30 amp at the tie. Okay, that's properly fused. You know what's wrong with this? It's supposed to be GFCI. In 1983, this wasn't required to be GFCI protected, but today it's a safety device. Safety devices get baked into the report as a deficiency. So your clothes dryer is not GFCI protected. Then we got our range. Furnace. Range down here. Range and water heater. Okay, on our water heater, not so much, but on our range, okay, 50 amps on the range, that's not unusual. On our range, we should have a lockout. What's a lockout? It's a little bracket. You turn this off, we've turned off the range. And then the little lockout fits in there so that somebody can't just wander through here. So while you got the range all apart in your lap, holding onto electrical parts, and somebody walks through here and goes, oh, look at here, well, that thing's tripped. Okay, so that's to prevent that. So we're supposed to have a lockout here. All right, are you through, bud? No, I'm not through. No, I'm not through. You see this? This is called handwriting. All right, see GE power mark? That's printing. Gold printing, load printing, center printing. The manufacturer, the International Residential Code, the National Electrical Code, and the manufacturer all feel like this should be printed and durable. Will this keep the breakers from working? No. You're going to ever have a problem with that? Only if it fades. Why will it fade? Because it wasn't printed and it's not durable. That's why. Okay. But gee, bud. You done yet? No. No, I'm not done yet. Okay, see these wires right here? These are ground wires, these bare copper wires, and they only carry current when there's an emergency. So under certain circumstances, we can actually double a ground wire because it's only expected to carry current during an emergency. So most of the time, this bar should be dead unless you have some crossover or some other problems. You should never assume, you should never just reach in there and touch it. One reason why you shouldn't touch it is because at this point, it's been bonded to the neutral bar. To the neutral bar, it goes out. Okay? So power comes out of here. It turns the fan. It goes back up into here. It goes there. It goes into the ground. You turn the switch off to the fan doesn't work. You still have power here, but you don't have power here. But anytime this is on, you have power here, in theory. You know, and in some cases, continuous. Some cases continuous. So what we have here is these are designed to carry load. These are only for an emergency. These should not be double lugged like that, right that. Okay? Some people call them tapped, double tapped. You can call it what you want. You can call it double tapped. I don't care. Honey Badger don't care. All right? But it's not supposed to be double lugged. Everybody can agree it's not supposed to be double lugged tapped. Tap lugged. Okay? It's not supposed to be. It's just not supposed to be. All right. Then our bonding location, primary ground at garage water heater. Okay, well that's the bonding location. But you know, he was close enough, and it was labeled, and that one note can be handwritten, and there it is right there. Okay, so that's our bonding for the electrical system throughout the structure. So what did we learn? We learned that our meter should be sealed on the other side. We learned that our grounding rod was not properly buried. We learned that we have bundling. We learned that we do not have protective booties. We learned that we have white hots that have not been properly marked. We learned that we do not have a lockout for the range. We learned that our clothes washer is not GFCI protected. We learned that our air conditioner is overfused. We learned that some of our neutrals are double lugged.